Welcome to Security Architecture Podcast, where we help cybersecurity professionals to stay ahead of the curve and ensure they are successful in their cybersecurity journey.
Hi, I'm Evgeny.
Hi, I'm Dimitri.
We have here Sriram from Akamai. Can you please introduce yourself and the company?
Hey folks, my name is Sriram Balasubramanian. I am a director of product at Akamai. I've been with Akamai for about 5 years now, and I'm very happy to meet with both of you, Dimitri and Evgeny, and talk about what we have to offer.
Excellent. So let's start with our first question and how you name the offering or the product that you have that addressing the ZTNA remote access.
Yeah. Akamai's product in the remote access space, which is built ground up on what we call zero trust access principles, is the product called Akamai Enterprise Application Access. What you'll see with Akamai is in many cases the name of the product defines what it does. So in this case, it's Enterprise Application Access. As a solution, this runs as part of what we call the Akamai Intelligent Edge. And this is the largest distributed edge service in the world. In fact, we jokingly say that Akamai was the world's first true SASE and was a SASE even before the concept came into existence.
We are very, very intrigued, and we are focused around architecture. So you intrigued us with the large one. Please explain more about the architecture. Please explain how you guys run the traffic, route the traffic, how people connect, high availability. You are more than welcome to share a screen.
Thank you, and I will take you up on your offer.
Perhaps also maybe it would be interesting to hear how being Akamai helped you in this journey.
That's actually a great question, and I think that will maybe that's the lead up into the architecture itself. We are the world's probably first SASE. We have the largest distributed edge network or edge delivery platform in the world. We are basically one hop away from 95% of all internet users, and basically globally have more points of presence than all competitors combined. What is great about this offering is that our offering is a collection of microservices that sit on these edge nodes and offer anything from site acceleration and performance optimization all the way to zero trust access, a secure web gateway, identity management, DNS security, and so on and so forth. This started with a simple idea. The simple idea was we wanted to make the internet better, faster, and more secure. The company is more than 20 years old, and there's a lot of learning that we've had in those 20 years. In terms of the platform itself, I'm not going to go through all of the numbers. I do want to say that we are present in more than 137 countries around the world with north of 3,900 locations. It is a massively distributed platform. Now, onto your specific question on access, the product we have is what we call Enterprise Application Access. That was built ground up on zero trust principles. And since both of you folks are very interested in architecture, I am going to jump straight into how the architecture works. The product is built on an identity-aware access proxy concept. So fundamentally, this operates through two reverse proxies, one facing the user and another facing the application. The reverse proxy that faces the application that users are trying to access, and remember, remote access is not anymore about accessing networks because the traditional VPN-based access to network resources is one that's caused the biggest problems in security. So we have a small piece of software that we call the connector that can run in customer data centers or IaaS environments. And this is the reverse proxy through which all traffic heading to application origins behind a firewall are traversed. Similarly, all user traffic, whether it's coming just from a browser without a client, or traffic that's coming through a thick client application, so think of your Outlook or SAP GUI or remote desktop, are sent to a proxy over TLS, and this proxy sits is what we call the Akamai EAA edge. Now, between the proxies, connection is dynamically stitched. So other key points, there is at no point of time do we poke into the firewall. All connections that go into the data center are as responses to requests coming out of the connector through the firewall on 80 or 443. And it's realistically 443 more than 80, because customers don't set it up for 80 any longer. Our actual access solution sits on 3 legs. So I think of this as a 3-legged stool. One, it is fundamentally identity aware, and which is why we call it an identity aware access proxy. 2, it is a full proxy that also does application delivery and load balancing. So you will find within configurations integrated application delivery capabilities as well as load balancing capabilities. Connectors are scalable horizontally and vertically, which refers to a piece of software that sits behind the firewall. And these connectors always operate in active-active mode. In terms of the third pillar, this is around the nature of the device that is being used to access. The solution also takes into consideration the posture of the device and how healthy it is to allow access to happen. Now, something that we will, as we peel the layers more, we'll find out is Akamai's remote access solution is one of the most flexible solutions out there. I call it as something that is designed to coexist with existing solutions in the enterprise where required and displace solutions in the enterprise where desired. This to me is very important because enterprises come into this journey of revamping their remote access, upgrading to a more secure position from different places. And if your offering is something that's designed around rip and replace rather than coexist, enterprises will struggle to adopt that. So this flexibility is what makes our solution unique.
The connectors, you can scale them actually vertically and horizontally. So you can have what kind of throughput you can actually process through one connector?
So since our solution operates in terms of users and applications, we don't really measure throughput in the purest regular concentrator sense. So each connector can support what we call thousands of active users and thousands of active applications. And you just scale them as you want to add more users or applications. The overall throughput for the connector depends on the pipe of the virtual hardware that you set up and the throughput that's available in the branch. We've had customers use our service with north of 70, 80,000 users active, simultaneously accessing resources with no issue.
Thank you. So this brings us to the question related to the licensing of the product. How do you license it? Is it based on users, based on connectors, or something else?
This is a very good question. We've looked at different licensing models in the industry. In many cases, even when vendors talk about licensing based on users, it's almost always in terms of concurrent users. We license based on active users as defined in entitlements. So an active user is somebody who accesses a resource after a successful login at least once a month. Our license is subscription based. And the advantage of this active user licensing is you pretty much end up paying for what you actually are using. It doesn't matter how many devices the user comes in from. It's still one seat from our service perspective. Nothing else is really charged for. We don't charge for connectors. You can deploy as many connectors as you need. Something we'll touch upon when we talk about other parts of the system is our integrated directory capabilities, our integrated identity capabilities. Nothing else is charged for. Everything is included.
When it comes to this product, can I have the Akamai Enterprise Application Access as standalone product, or it's an add-on on already existing service or solution?
Akamai Enterprise Application Access can operate as a standalone product. As a standalone product, should you require it. If you are an existing Akamai customer and you want to add it to your current catalog of products that you have from Akamai, we support that too.
You mentioned that you guys tied to identity. Can you elaborate more how it's actually working?
Wonderful. That's again a great question. As I told you, identity is one of the key pillars. And with respect to keeping the principle of coexisting where required and displacing where desired, what we do is within the product is a native IDP that has multi-factor authentication capabilities, as well as a cloud directory for users to use in case they don't want to hook up to their on-prem Active Directory. We also support SAML and OIDC-based integrations to a variety of third-party identity providers. I have some of them in the slide here. We have what we call named identity providers in Azure, Okta, Google, OneLogin, and Ping1 Identity. And we can support any other third-party identity provider. We typically operate by being in those modes, either a SAML SP or an OIDC entity when interacting with that specific identity provider. So if a customer has a choice of identity provider, we can just work with it.
So let's talk a little bit about the ways of consuming the service. Most of the people today are either working or browsing the internet through the browser. And there are different types of approaches here. Some of the solutions are using client or agent that have been installed on the endpoint, and some of the solutions providing ability to go clientless. Do you support both? One of them?
We support both models of operation, and you can have them coexist together in your environment. So any application that is HTTPS based can be supported without the need for a client. We also support a browser-based RDP rendering solution as well as a browser-based SSH rendering solution. And this extends to other VDI types like VNC. All of these can be supported without the need for a client. Now, if there are certain applications that use other protocols or ports beyond the standard HTTP, HTTPS or RDP SSH, we allow customers the option to download and install a client either through our user workspace, which is tied to the identity experience, or through a software distribution system like SCCM. And once installed, the client will allow users to access any service over their TIC client applications. Now, the solution is built ground up in terms of keeping least privileged access in mind, and this extends everywhere. So, for example, if you are a user in the organization, and let's say Dimitri only is accessing applications over a browser, you will not even see that identity that you're using to authenticate has the ability to support a client. Now, if Ginny, working in the same organization, requires a client, only then will you see the ability to download a client show. So at no point of time is anything internal ever made visible to the user, or is any access to internal resources allowed for the user without going through our proxies. And so there's full obfuscation everywhere.
So you're actually preventing the users that not supposed to access on, I would say, non-standard ports to download the client. So they will not even have this ability.
From protocol perspective, if I'm working from home, I may need to share a file or have a phone call. Can you elaborate more about what kind of ports and protocols are supported? VoIP, file share, printing, password changes.
So in terms of protocols, we support pretty much any protocol over TCP and UDP across all ports. We do, just in terms of pure zero trust principles, we don't support peer-to-peer, so we don't support any server-initiated connections. We don't support scenarios where a peer is trying to directly connect to another peer. And that seems to work in most models. For example, let's take printers, right? Invariably, there's a print server sitting somewhere in the enterprise that the user devices connect to. If you are in your home and doing local printing, that traffic should never go through us, right? It should be a user machine hitting the local printer. And how our client works is it intercepts only traffic that you've asked it to intercept and send over the proxy. The rest of it just goes locally. File servers, similarly, we support most file service protocols. If you take something like FTP, that's active and passive modes of FTP. I think the active mode is server initiated and passive it's not. And so if it's not server initiated, we will support it. If it's server initiated, just for zero trust reasons, we don't want to go and support it.
How would VoIP work in this case?
What we have customers do, and in fact, this is recommendation from most VoIP providers, is to have their call manager sit in the DNC. So it goes over the direct internet for all call exchanges, and we probably not want to get in the path. Getting these kind of proxies in the past when you're trying to access services over the internet often leads to increased jitter, latency, and call quality. Now, the call quality degradation. Now, the other realization that we have is calls like these, which is how most business is now being conducted, is happening on the internet. It's not going behind the firewall. So as those models move to an internet-based service, we have offerings like a secure web gateway to protect and optimize those calls for that head to services in the cloud. SWC offering is called Enterprise Threat Protector. It's a sister offering to Enterprise Access, and we also offer a more holistic product, which is what we call the Enterprise Defender. So let me break this down a little bit further. So one of the other advantages to a proxy architecture is that you can chain other services in front of it or on top of it. So for example, Akamai is very well known for its content distribution and content delivery capabilities. As users continue to use the internet to access content that sits behind the firewall, the biggest problem they face is performance. They keep complaining about things being really slow, and enterprises have to solve the problem by duplication. So they build data centers all over the world, and users are connected to the core process data center. What we offer, being this big giant overlay on top of internet, is maximum performance optimization that we do across layer 3, layer 4, and layer 7, as well as content caching. So this service is just chained to the Akamai Enterprise Access service to provide highly performant access. The other variation to this is again a problem that gets exposed because of the internet. Traditional applications in the enterprise, depending on the enterprise you talk to, you might have applications that are 10 years old and 15 years old and sometimes even 20, 25 years old because enterprises grow organically. A lot of these applications are not exposed to the modern attack vectors and therefore are not always built ground up to be protected from these modern attacks. We can, with Enterprise Access, service chain our layer 7 WAF solution, which also sits fully in the cloud. And you can instantly bring in world-class DDoS protections, prevent complex attacks like SQL injection, cross-origin scripting attacks, and so on and so forth, without having to go and touch your application. I think the highlight of all of this and all of what we offer is that you don't need to go and make changes to your application. If I have 30 more seconds, I want to talk about another interesting part of the architecture that is also very valuable and close to the identity conversation we had. One thing, as I mentioned, is that we bridge with third-party identity providers, and we also have our own IDP. What we also do within EAA that's really unique is what we call authentication bridging. Because we have these two proxies in place, we can separate user-facing authentication from application-facing authentication. So, for example, you could have a user authenticate to an Azure or an Okta over SAML, and in the back, the application which is being used to Kerberos constraint delegation can automatically get single sign-on. So this seamless single sign-on can, extend in any permutation combinations. You could have a user logging into our IDP and single sign-on to an application like RDP service that requires NTLM. You can use a form-based login and from there go into custom header injections. So the ability to do authentication bridging brings seamless single sign-on, which not only improves the user experience, but also leads to much better reporting. Because for every access that a user is doing, you know who the user is, which user belongs to, and what the user was trying to access.
How this solution works, if I'm connected right now to my work and I'm doing some operations over SSH and I'm roaming between networks, what would happen to my connection?
In terms of scenarios around roaming, your connections, we don't disconnect connections when user roams. So for the longest possible time, either through retries on the client or retries between the browser and our service. We try to keep the connection alive. In the event that as part of the roaming activity, the connection itself does get disconnected. Once the user connects back to the network, while a new connection is established, authentication is set up in the back through the single sign-on that they had already done, which is potentially stored as a cookie in the user machine. So the user can just continue from where they left off.
So, Sriram, it would be great if you could show us a little bit the product itself, how it works and what it does, and how you're using it.
Okay, wonderful. So what you see here is the administrative interface of the product. As I mentioned, the product has both an end user workspace and an administrative interface. We will dive into the details of the administrative interface if we have time, but like everybody else, you want to first see how the end user experience looks like. So as an end user, I can either use the Akamai's EA's identity service to authenticate and authorize the user, which is the case here. And I provide credentials to log in. So I'm going to first log in as myself into this workspace. Once I log in, it establishes posture. On successful posture, you'll see land into what we call our categorized user workspace. This page is very customizable, of course. There's a collection of different categories that you set up, and there are a few favorite icons sitting here and there. So from here on in, you can single sign on into a wide variety of different applications. So for example, let me show you just a quick SSO happened to an RDP machine over my profile. So you see it's reading a user ID and applying my profiles to it as it RDPs into a remote desktop. Now this is rendered over HTML5 on our end, but it also offers a lot of other powerful capabilities like file sharing and adjusting other settings. But it's not always that I would want to go and RDP into a machine. In some cases, what I want to do is not RDP into the machine, or what I want my user to experience is just the application itself. There's always a risk of exposing your entire remote machine to a user. So what EA offers that's unique is you can just allow RDP for a particular application. In this case, this is an RDP for just WordPad. As you can see, this screen is, of course, Windows wants me to install updates, but this screen is basically a rendering of WordPad, and as a user, I cannot do anything further with it. Even if I try to install updates, it's not going to allow it.
So I have a question. If I'm as an administrator, can I record the session of the RDP of somebody's what they're doing? If I have people that are not full-time employees or
that's a great question. That's something that we are considering building into the product. We have the capabilities. We've just not exposed it yet. What we also do in terms of recording is we also offer SSH over the browser. And since SSH is connecting to more critical applications typically, we support SSH recording today. So you can audit SSH sessions. RDP is something that we are considering bringing into the product as a next step.
From a reporting perspective in general, can I do reporting on behavior or anything suspicious? Or in general, what kind of reporting is available?
There's a lot of reports that are available. We have what we call preset reports, which is a set of reports that we build and make available based on best practices. We also have a full-fledged application access report that shows pretty much everything you want about that user access. So, for example, this is a behavior-based login failure event that we record, where you see that somebody has used my username, but has provided invalid passwords. And when you see this spike up all of a sudden within behavior, you know that something is going wrong. Similarly, you can, from a map view, see where the users are, or you can go and get a user detail report that should also tell you who the users are, what IP address they are coming from, and which country they were coming from, among other things. And if you all of a sudden see a user show up in the US and then 2 minutes later in a different geography or a different country, that's a geo-velocity flag. What we have also seen is customers want to consume this information not through analytics within the product, but through a centralized analytics solutions like a SIEM, for example, a Splunk. So we have apps and the ability to export all of our logs into any SIEM collector the customer wants to collect it to, for them to build complex rules and reports. Now, just like you have user reports, we have reports on admin events, we have reports in the product on access itself, which is a generic application access report that I can run. And I can also see, this is a generic application access report that shows a lot more information, including the device posture, state of each device that me as a user was using to access and the app that I was trying to access. I can also go and look at audits. So we were just talking about recording, right? So I'm just downloading an SSH audit, which was a recording of my access on the SSH machine. And it just shows up as a text file. If you can see my text screen.
Sriram, thank you very much. We're actually done with our official part of the show, and we want to open this to open discussion, and I have a few questions. So if with the client running, it's provide remote access. What if a client customer using some kind of web proxy? How does it work together?
So with the client running and providing remote access, if a proxy is in the middle, there are a few things that we can do. So how the client operates is by identifying an origin in the cloud that the customer defines and sending all traffic encapsulated over a WebSocket TLS connection to the origin. Now, since this is a publicly available origin, the simplest thing that we advise a customer to do is to make it an allowed origin. If your company is acme.com, as long as that origin is something.acme.com, invariably all on-prem proxies will allow the traffic to pass through. The second option is obviously to whitelist particular traffic, which I would not recommend, and I don't think most customers would like. We also are, and then I'll break it. If the access is going via a browser, the browser automatically detects the native settings of the device. And so in these three variations, we typically have customers who use on-prem proxies use our service along with it. Okay, I wanted to show a product demo where I want to show the performance improvements. Is there time for us to do that?
A couple of minutes, yes.
So in terms of demonstrating other capabilities of the product, I wanted to show you both the client functioning as well as some of the performance improvements that I keep talking about. I have a client that is running, but that's tied to an Azure IDP. So I'm going to first log into the client. And what you would see is our login is tied to the user browser. The advantage of tying it into the user browser is that the user gets a seamless single sign-on between their cliented apps and clientless apps. Now, we designed the client to be as not intrusive as we can make it. So if you really want to see what's in the client, here's a quick view of the client. It tells me a lot of information about myself, and it also has some advanced functionalities. But now that I have the client on, what I'm going to do next is remote desktop into a machine. Now, I have two machines in Singapore. One that's accessed over a regular channel, another that's accessed over the accelerated channel. So when I RDP into the regular channel, and I, as a user in Seattle, I'm trying to access this machine in Singapore, what you will start to see once this loads is a view into the overall bandwidth that the connection is consuming. Now, to do that, we are using a tool that was, I think, shown in Ignite recently called Remote Display Analyzer. If you can see the tool, you see the round trip latency at 366 milliseconds and the bandwidth output at 3 seconds, or 323 kilobytes and so on and so forth. And the overall available bandwidth as detected is about 4 megs. So this numbers will change slightly if I'm trying to access, say, CNN.com. Now, this is a machine in Singapore that's trying to go to CNN.com. And the results are being rendered over an RDP connection to me. the latency still remains around 300, 400 milliseconds, and the available bandwidth is 65 megabits. Now, if this same machine was, however, accessed over our accelerated path, which Akamai offers to its customers, let's see how the experience looks like. It's the same machine. As what you can see is we've cut the round trip latency by half. What went to 400 milliseconds is 160 milliseconds. And this is part of why customers choose to use our service and the acceleration rather than building data centers all over the world, because the performance and latency challenges go away. And if you look at the available bandwidth, it's starting to go up. When I try and access the same page, you should see more of the performance as I scroll down. The bandwidth is more than doubled here, and the output is also in 3 and 4 megs. This is something that's very unique to what Akamai offers in its access solution, and this is why we really are proud about this solution and compared to other offerings in the market.
Thank you. This is very, very interesting. Sriram, thank you very much.
Thank you so much. I'm very glad to be able to talk to both of you today. Thanks for the opportunity to showcase our product, and please stay safe.
Please remember to subscribe to our podcast and join us for our next episode.